All right, guys. For today, we're going to do one more problem, kind of picking up where we left off yesterday. So we'll do one more of those, and then we'll get into some of the more trickier stuff for today. Not terrible, just got to be real careful what you're doing, okay? All right, so for number 5, what is the first thing we need to do in order to solve this? Good. Add the 4. We want to get the radical part by itself. Hey, guys, enough. All right, so we're trying to get the radical part by itself first, so we have to add the 4. Then what? Good. Divide by 2. The radical needs to be totally by itself. What about from there? Alyssa, what did you just say? Before I can do the reciprocal, I got to do something else first. I got to switch that. This is not written in the right form for me to do the reciprocal part. Right, so this should be x plus 2 to what power? Three over 2. Right, the root is a 2. Roots go underneath, and then the exponent goes on top. Whew, that was painful, but we got there. Right, so that's switching that into the form, because I know a lot of you are like, oh yeah, do the reciprocal, but you got to remember to flip it in that form first, then we can do reciprocal. What was that weird rule yesterday? Even what? Even what is plus minus? Good. If the denominator of the reciprocal is even, then it's plus minus. Again, it's that weird, kind of weird rule. So when I raise both of these, what power am I raising them to? Good. 2 over 3. Because again, by raising it to the 2 over 3, if I look here, this would give me 6 over 6, which is just 1. So that's just x plus 2. What is 125 to the 2/3 power? Is 25. Good. The denominator of the reciprocal is odd, so I don't need the plus minus. And then just subtract the 2. So x equals 23. All right, that was kind of the continuation from what we did yesterday. Is there questions on that? Biggest thing is remember that weird quirky rule. If the denominator of the reciprocal is even, it's plus minus. You have a worksheet tonight that's two-sided. The front side are problems like this, like what we worked on yesterday. Well, it always does a little bit, right? Just hang with me. It's bringing up some stuff you've done in the past. All right, guys. So part 3 is solutions that don't check out. So we've talked about this before. We've seen it a lot in chapter 8, where you go through, you solve this whole thing, and then all of a sudden you get an answer that you go back and check it, and you're like, wait a minute, that doesn't actually work. Okay, so that's one thing we need to watch for. Do you remember what those are called? Good. Those are extraneous solutions. Now, as a good math teacher, I should tell you that you should check every single answer every time you solve. As a lazy mathematician, I'll be honest, I don't check everything I do. I trust my abilities that I solved it right. But there are certain problems that you have to check, and this is the type. If your original problem make a note of this. If your original problem has an x on both sides of the equation, you must check your answers. All right, so you have to check. So what's going to happen is you're going to see an x on one side, and then you're going to see an x on the other side, and I can't actually put them together because one's under a radical and one's not. So you got these two x's, but I can't do anything with them from the start. If that happens, you need to check them because sometimes extraneous solutions happen. Okay? So take a look at number 1. You can see how I have an x on both sides of the equation, and I can't actually put them together because because one's trapped under the radical, one's not. So I cannot put them together. So this is one that I'm going to have to, when I solve, I'm going to have to check my answers to make sure they actually work. All right, so is your radical by itself? Yep. So how do I undo that radical? You square it. And if I do something to one side, I have to do the same thing to the other side. So we end up with 3x minus 2 equals x squared. Think back, how do you solve an equation that has an x squared? Very nice, equal it to 0. I'm going to move everything to the right since my x squared is positive on that side. So x squared minus 3x plus 2, moving everything over. I know it bothers some of you because I put it on that side. But what do I do once it's set equal to 0? We factor it. Yay! That's what you meant to say, right? What are your signs? They're both minus. Options for A. Options for C. Will that make a 3? Yes. Okay, so I know I factored it correctly. So then what does x equal? 2 and 1. Now, I do need to go back and double check to make sure my answers work, because again, sometimes they are extraneous. So if I plug this back in, 3 times 2 is 6 minus 2, 4. You guys can all talk to me, it's okay. And the square root of 4 is 2. So if I plug this back in over here, 2. So does this equal that side? Yeah, that one works. Check the 1. How I'm checking, I'm just plugging into the original equation. Yeah, the original before I started writing on it. So I plug in a 1. What's 3 times 1? Minus 2. 1. What's the square root of 1? So if I plug it on this side, 1. So it works. Okay, so both of those are good answers. Because sometimes what happens is you get like one side, you're like, yeah, the square root of 4 is 2. And then you plug it back in on the other side, and it's like negative 2. 2 is not the same as negative 2. So you got to be careful. Okay? You just want to make sure each side of the equation equals the same thing when you plug it back in. Okay, so number 2. What's the first thing we need to do? Add the 3. What's x plus 3? It's x plus 3. If you write 3x, you've turned it into a multiplication problem. All right, so x plus 3. Am I going to have to check this answer? Yes, I'm going to have to because I have x's on both sides. How do I undo the radical? Okay, we'll square it. So we get 11x plus 3 equals, now be very careful, is wrong. You cannot distribute an exponent into something that has a plus or minus holding it together, because that's one whole piece. I can't do that. What? It's not it. What does it mean to square something? It means you times it by itself. Now how do you multiply that? Bless you. We're going to distribute that. So we get x squared. Ooh, what am I doing? Plus 3x plus 3x plus 9. So be very careful when you see a quantity squared. Remember, when squaring means to multiply something by itself. So you actually have 2 of those that you need to multiply together. So 11x plus 3 equals x squared plus what? Just 6x. I have an x squared, so we need to set it equal to 0. I'm going to make y'all mad. I'm going to move it to the right again. So x squared, subtract the 11x over, negative 5x, subtract the 3, positive 6. Ooh, what's that 6, 5 combo? You guys remember that? What are your signs? Both negative? Options for A? What did I do with what? I moved it over there. And I subtracted 3. That's where I got these. It is 2 and 3. Be careful, because 1 and 6 can also make a 5, but you'd have to have different signs. So what does x equal? 2 and 3. Should I check them? Go back to the original problem when you're checking these. So 11 times 2, 22 plus 3, 20, it's square root of 25, it's 5, minus 3 is 2. So that one worked. Try the 3. 11 times 3, 33 plus 3, square root of 36, minus 3, and that one worked as well. Okay. So honestly, guys, for checking purposes, a lot of times it's easier to check if you just check them in your head. Okay. Some people get all caught up and try typing everything in the calculator, and it makes it sometimes more difficult that way. All right, how about this one? I don't have a radical, but I have a fractional exponent. So what do I do first? Add the 4. Good, that'd just be x plus 4. How do you undo the 1/2 power? Yeah, multiply by the reciprocal. 2 over 1. Am I going to have the plus minus as part of this? No, my denominator is odd, not even. Good, x plus 6. Good, this means I have 2 of them, so I really have x plus 4 and x plus 4 that we need to multiply together. So we'll have to distribute this. X squared plus 4x plus 4x plus 16. Are some of you at the point where you're starting to do that in your head? Good. All right, so if I clean it up, x squared plus 8x plus 16. Good. I need to move it over. So x squared, I'm going to subtract the x. It would give me 7x. Subtract the 6. It's 10. Can I factor that? What are your signs? So x and x, and what's my c? 5 and 2. So x equals -5 and -2. Do I have to check these? Yes, I have to. So when I go to check this, okay, if I plug in -5, what's -5 plus 6? 1. What's 1 to the 1/2 power? Is 1. Minus 4 is -3. No. Definitely not it. That did not work. Try the... Yeah, it's extraneous. No, it's just not a good answer. Because if you tell me it works and it really doesn't, then you're wrong. Okay? Check the number -2. -2 plus 6 is 4. 4 to the 1/2 power is 2. 2 minus 4 is -2. It worked. What's wrong, Jordan? Why does it work? Because -2 plus 6 is 4. 4 to the 1/2 is 2. 2 minus 4 is -2. And if I plug a -2 on that side, it works. That actually did work. All right, so do you see how sometimes you could have an extraneous answer on there? Okay. Whoa, there are 2 radicals going on in there. Are those radicals like terms that I could like combine them together? You're right, technically. No, I cannot. They are different. He thought I was going to yell at him. Did you see the look on his face? So, is my radical by itself? Yeah, right? They're both by themselves. So what do you think I should do? Square it. Right? Whatever I do to one side, I do to the other side. That's legal in math, right? As long as I'm fair and I'm balanced. So what happens to my radicals? They both go away. And all I have is 2x minus 7 equals x. Do I need to set it equal to 0? I don't have an x squared. No. If it has an x squared, we set it equal to 0 because we have to factor it. But if it's just a plain old x, I can just solve. What? These? Yeah, anytime you have an x squared that shows up in the midst of your solving, you have to set equal to 0 so you can factor it. Here I don't have an x squared, so I don't have to set equal to 0. I'll just subtract 2x. So negative 7 equals negative 1x. Divide by negative 1. So x equals 7. Do you have an x on both sides of your equation to start with? So I need to check it. You got to check. Anytime you see an x on both sides, you have to make sure you check that. So plugging 7 back in. Again, I'm going back to the original before I started writing on it. 2 times 7 is 14 minus 7. Square root of 7, not pretty. But if I plug in a 7 over here, I get radical 7. Are those the same? Yeah, sure are. So I'm good. I'm just checking to make sure that each side of the equation is the same. Are these equal to each other? Yeah, I don't care what the value is. As long as I'm seeing that this side is equal to the same thing as that side, I know I'm good. Yeah, if it's an ugly decimal, I'm not going to write that down. What about number 5? Try this one on your own. It's just like the last one. Try it on your own. All right, guys. So looking at this problem, your radicals, are they already by themselves? Yeah, they're already all by themselves. So we'll go ahead and square both sides of the equation, which makes your radicals both go away. So we have 8x minus 4 equals 4x minus 12. Do we have to set this equal to 0? No, because you don't have an x squared. So we'll go ahead and solve. So 4x minus 4 equals negative 12. Add 4. 4x equals negative 8. Divide by 4. X equals negative 2. Do you need to check your answer? Did you have an x on both sides of the equation? You did. You need to check this. So again, you go back to the original problem, and we plug it in. So 8 times negative 2 is negative 16 minus 4. It's negative 20. So I get radical negative 20. Let's see if it works out on this side. Plug in a negative 2. 4 times negative 2 is negative 8 minus 12 is negative 20. Does it work? Yeah, it's the same thing on both sides. So that right there is a good answer. Okay? All right. Let's take a brain break. So number 6 looks kind of like our last problem, right? Like 1/2 power is the same thing as a radical, right? Okay. So, but they're on the same side of the equation right now. Could I actually put them together? Are they the same? 5x plus 7 is the same as 2x minus 5? No, they're not the same. They're different. So what happens is we need to make this look more like what we had back here, where we had like one on one side, one on the other. Each one was by itself, right? That's kind of where we need to go with this. So before I move this, because I want to make sure everyone's clear, if I would have like 3x to the 4th minus x squared equals 0, if I had something like that, and I wanted you to move this to the other side, what would you do? If I wanted you to move this, you'd add x squared to the other side, right? And it would just become a positive x squared over there. But the x squared didn't change at all, right? Just the sign in front of it. Okay, so when I move this piece, this right here was like a giant x squared. Let's in this example. So when I move this whole piece to the other side, I'm going to, instead of it being minus, when it comes over here, it becomes a positive. Does this change? No, it does not. I want to make sure we're clear on that, because this is like a radical over it, which holds it as one big group. I can't touch it. So the first one's going to stay the same. This whole piece will move over here, but the entire piece is kind of like now there's a plus in front of it instead of the minus. Inside that parenthesis did not change. I want to make sure we're clear on that because everybody tries to change every sign in there. For what we are doing in this chapter, yes. There are issues where other things happen and other problems, but we're not going to do those. All right, so what do I do next? I got each part by itself. Good, I'm going to do it to its reciprocal, which would be 2 over 1. So what happens to both of those exponents? They're just 1, so I don't really have to write them. So we'll have 5x plus 7 equals 2x minus 5. You all right? No? Do I have to set this equal to 0? No, I do not. So I'll just go ahead and solve. Subtract 2x. 3x plus 7 equals negative 5. Subtract 7. 3x equals negative 12. Divide by 3. X equals negative 4. Do I need to check this answer? Yes, I do. Because you had 2 different x pieces in here that I could not put together. Always go back to the original problem to check it. Okay? So if I go to plug this back into the original problem, we have 5 times negative 4. I need you guys to talk to me here. That's negative 20 plus 7. It's negative 13. So I have negative 13 to the 1/2, which is not pretty, right? Minus, let's do this one, 2 times negative 4. Negative 8 minus 5. It's negative 13 to the 1/2. Does this minus this equal 0? Yeah, you subtracting the same thing from itself, you get 0. So it does work. You okay? Like if I had 4 minus 4, you'd be like, well, yeah, 4 minus 4 is 0. It's the same thing subtracting from itself. Last one. But look at it. What's wrong with it? They're different exponents. Uh-oh. My last one, they were the same, right? Well, let's kind of go through one step at a time. Right away, I know I need to get each piece by itself, right? So I need to move the one piece to the other side. So 11x plus 45 to the 1/4 equals, when this whole piece moves over, instead of it being a minus that piece, it's going to be a positive that piece. Now, let's do a little thinking. See what you guys can come up with here. I need to raise both sides to the same exponent, but I need those fractions to go away. Common denominator. Not GCF, common denominator. Yeah, what would the common denominator be? 4. 4. So make yourself a note. If the rational exponents are not the same, raise each side to the common denominator. Ooh, I can't spell. So if one of them had a denominator of 2 and one of them had a denominator of 3, what would you raise them to? What's the common denominator between 2 and 3? 6. Okay. So let's go ahead and take a look at this one. So I'm going to raise each of these to what power? To the 4th, or 4 over 1. So I want to make sure we're clear on what's kind of going on here with these. The reciprocal. Eli, think through it this way also, okay? Here, if I had done 1 over 4, you'd get 1 times 1, and 4 times 4, you'd get 1/16 power. That doesn't help you, okay? Here, if I do 4 over 1, I get 1 times 4 is, 4 times 1 is, and 4 over 4 is 1. Yeah, where you just, yeah, like the, oh, what is it? Say Moses, Moses, Moses. Hoses, hoses, hoses. Noses, noses, noses. Who built the ark? Most people would say Moses. Because you've just like trained your brain to say those words. I've never heard it as a fork one. He has no idea what he's talking about. What do you eat soup with? A spoon. It's the same thing as the Moses Noah ark thing. All right, so here we go. Anyway, back to this. Right? All right, guys, back to this. So this side cleaned up just fine. Look at these exponents, though. Children. Anybody North Baltimore? Okay, here we go. So on this one, 1 times 4 is 4. 2 times 1, what's 4 over 2? 2 over 1, or 2. So this is actually x plus 5 squared. So you'd have to do x plus 5, x plus 5. Okay. You're multiplying. When you do exponents like here, you distribute, so you multiply. 1 times 4 is 4. 2 times 1 is 2. 4 over 2 simplifies to just 2. So my exponent is a 2. Same way here, this gave me 4 over 4, which is 1. So this to the first power, I don't actually have to write it down. Oh, I saw a light bulb go off. And this kind of deal only happens when you have different fractional exponents. You got to really watch for that. So from here, you're going to have this as x plus 5, x plus 5. So we're going to multiply that out. So we get 11x plus 45 equals, when I distribute this whole thing out, you guys okay if I take a little shortcut here? X squared plus 10x plus 25. I just distributed all of that, did it in my head. Apparently I can't skip steps. I distributed all of this, and I get this. Ooh. All right. Anyway, we have, I know, right? I'm telling you. All right, guys, we have an x squared, Eli. So we need to set it equal to 0. So x squared, subtract 11x, gives me negative 1x. Subtract 45, negative 20. And then we have to factor that. What are your signs? We have x and x. What about for c? What? 4? Good. We have positive 4 and a negative 5 because you're trying to get the negative 1 in the middle. So x equals negative 4 and 5. You're right. That's what we get, but does that really work? Hold on, guys. How'd I get what? Are you okay that we raised this to the 4th power? Because that was my common denominator. So when I raise it to the 4th, you get 1/2 times 4 over 1. That gives me 4 over 2, which is 2. So you still have a squared left over up there. That's what we've been doing since yesterday too. When you raise an exponent to an exponent, they multiply. All right, so what did we get? -4 and 5? So let's check these. If I plug in -4, what's 11 times -4? -44 plus 45 is 1. What's 1 to the 1/4 power? It is 1. Whew, that was painful. All right, so that gives me a 1 minus, let's plug it in over here. So -4 plus 5 is 1. What's 1 to the 1/2 power? 1. 1 minus 1 is 1/2 power means square root. What's the square root of 1? Plus 1. That's 1/2 power is the square root. Remember, the part underneath the fraction, that's the root. So it's asking you what's the 4th root of 1. What number times itself 4 times is 1? 1. No. All right, take a look at the other answer. We said 5. Let's make sure that one works. Guys, 11 times 5, 55 plus 45 is 100. So I'll write it in this other form to make him feel better. So the 4th root of 100, is that pretty? No? Okay. Minus, plugging in 5 here, 5 plus 5 is 10. Square root of 10. If I subtract those, do I get 0? Yes. Yes. Grab your calculator. Grab your calculator. Type it in. Because Eli was confused when it was raised to an exponent. You could type it in as 100 to the 1/4 power minus 10 to the 1/2 power. Are they the same? When you subtract them, do you get 0? You do. Something should have kind of thrown you. Look at the difference in these numbers. 10 is 100. You can make 10 into 10 squared is 100. This is an index of 2 times 2 gives you 4. They're just written in different forms, but they're the same thing. So both of these answers, in this case, actually, they do work. Well, on something like that, most things we've been able to kind of just do in our head and be fine. But if you get something that you're like, yeah, I'm not entirely certain, just type it in, make sure it works. Okay? All right.